in the test we had this problem which says, question number 22, prove or refute if magnitude of A equals to magnitude of B is equals to magnitude of C is equals to magnitude of vector D, then the magnitude of A plus B is equals to magnitude of C plus D. Now, to prove it, what we can do is we can take some examples, right? So let me take an example where this could be true, right? We are talking about magnitude, but not direction. Vector is magnitude plus direction. That is it, right? So this statement is actually true only if all are in the same direction. All are in the same direction. That means if A vector is equals to B vector is equals to C vector is equal to D vector, then it could be true, right? It could be true if A and B and C and D are in opposite direction. You understand? It is true even if the vector B is equals to minus of A, and if vector D is equals to minus of C. These are the only conditions when this could be true. Otherwise it is false. Else it is false. Right? So that is, I'm just telling you this so that sometimes the question could be, when can it be true? Right? So basically we say that this statement is false, not correct. False statement. Right. Now, to show you the answers, let us say if we have all the vectors in the same direction, like this, right? We know they are equal vectors, they're in the same direction. Their magnitudes are also equal, right? You add either two of them, you'll get the same result, whether it's A plus B or C, D, whatever, right? So that is one option when it can be true. The other could be that this is A for us and B is this. Then A plus B will be 0, and then this is C for us and this is D, right? And C plus D is 0. That is, we have set of opposite vectors. Then it is true, right? But otherwise, in general, let us say this is my vector A, right? And this is my vector B. In that case, AB will be this. Do you see that? But if I have this as my vector C, right? And my vector D is kind of like this. In that case, the sum will be this. So depending on their direction, their relative directions, right, we have different scenarios. If we have like this, for example, the sum will be this much. So sum is different in all the cases. Do you see that? If my vector is like this and the other one is like this, then the sum is 0. Do you see? So it could be from maximum of, so maximum is how much? Maximum is when my vector 1 is like this and the other one is like this. Do you see? So it varies from 2 times A, I can say, to 0 vector. So their sum could be anywhere between 2A to 0. So it is never same, right? And it is same only in these two cases. So that is how we can prove or refute this particular case. I hope you understand the concept of vectors, the opposite vectors, right? And scalar multiple. So this, right? So what we have here is direction, which plays a critical role. Vectors of same magnitude are not same. Only their magnitude is same, right? So when we add the vectors, then we are adding them as shown here, making a triangle or parallelogram. So in a triangle, you know, the third side is always different from the other two depending on the angle between them, right? So that is a way you could say and prove it. So when we add vectors a and b, then really what is the angle between a and b? That makes the difference between sum of a and b, right? So in c and d also, their magnitude may be same, right? But the angle between them is critical. So basically you can write that absolute value of a plus b is equal to square root of absolute value of a square plus absolute value of b square minus 2 times, so 2 times absolute value of a, absolute value of b, cos of, I can write 180 minus theta if theta is the angle between them, right? So when it is 180, let me write 180 minus theta, where theta is angle between them, square root. So that is the answer, right? So it is not just a square plus b square. This factor 2ab cos of angle between them makes a huge difference, right? Where we are assuming that angle between the two vectors which we are adding is theta. That is the angle theta. That makes huge difference, as you can see, right? Correct? So cos 180 minus theta is actually plus theta, so you can at times write plus 2ab cos theta, right? That's an alternate way of writing sum of vectors. So that is how we can explain that this statement is incorrect. I hope you understand. Thanks and all the best.